So in previous semester, you have learned about the influence line diagram. Influence line diagram, if a moving unit load passes over a beam or structure, any type of structure, what should be the variation of the bending moment, shear force, reaction, torsion, or any other stress? Okay, what should be the variation? If you plot these things, this is called your influence line diagram. Okay, so suppose if you recap it, suppose 1 minute. So suppose an influence line is a graphical showing for any given beam, frame, or truss. The variation of any force or displacement quantity, such as shear force, bending moment, tension, deflection, for all the position of the moving unit load as it crosses over the structure from one end to another. Okay, this is important. That means for all position of the moving unit load. Okay, so a unit load pass over a structure. So what should be the variation of the bending moment, shear force, tension, deflection, like this type of parameter you can obtain easily from the influence line diagram. Okay, so suppose there is simply supported beam. You have learned, just this is a recapitulation. So if this is what should the, if a unit load varies here. Okay, so what should be the variation of the shear force at this point? So this variation is like this is x by L, and this is L minus x by L, and this will be negative, this will be positive. If you consider this is negative, this will be positive. What should be the variation bending shear variation of the bending moment at any section? Suppose at x distance, it will be this one. This ordinate will be x into L minus x by L. Okay, now what should be the variation of RA, reaction at RA? So this will be reaction at RA. This will be 1, and this will be 0 here, and reaction at B, this will be RB, and this will be 0. Okay, so these are the criteria, these are the uh, basics of influence line diagram. And before going to this, you have to learn about this influence line diagram. Okay, so this is the reaction at RA. Okay, a point is the reaction, the influence line diagram of reaction at RA. This is the influence line diagram of reaction at RB, and this is the reaction. This is the shear force at any distance from x. At any distance x. Okay, what should be the shear force diagram? This will be x by L, and this is L minus x by L. Okay, and bending moment. This is x. This is this quantity will be x into L minus x by L. Naturally, you know. So this is the influence line diagram of RA, influence line diagram RB, influence line diagram of RB, and this is the influence line diagram of shear any point x distance apart from A. This is influence line diagram of bending moment at any distance apart from distance x. Okay, so I think you know this. তোমরা এগুলো পড়েছো তাই তো? Okay, পড়েছো?
Yes, sir.
হ্যাঁ হ্যাঁ, you have go to this uh, influence line diagram. Now come now it is very much difficult to draw the influence line diagram of indeterminate structure. Okay, so it is very difficult to go to the influence line diagram for indeterminate structure. To outcome this problem, you have to go to the Muller-Breslau principle. Okay, Muller-Breslau principle says that the ordinate of the influence line for any action in a structure equal to those of the deflection curve obtained. 1 minute এগুলো হয়ে গেছে। So the ordinates of the influence line for any action So the ordinates of the influence line for any action, okay, in a structure is equal to those of the deflection curve obtained by releasing the constraint. You have to and corresponding to the action and giving it the unit displacement in the direction of action. Okay. So first, suppose you are according to this definition, suppose you are going to draw reaction RA. So this is your beam, and you are going to draw the influence line diagram of RA. So naturally, you know, this is the RA and this is the RB. So what it says that the ordinates of the influence line for any action, you in order to determine the ordinates of the influence line for any action, suppose we want to determine the any action, here action is RA, okay, in a structure RA এর আমি influence line diagram draw করতে চাই. So RA in a structure are equal to the deflection curve obtained by releasing the constraint. So I have to first release the constraint, okay. So if I release the constraint, it will look like this. First release the constraint. So RA in position of RA, you have to release this constant, okay, and then corresponding to the action. So in the corresponding to the action, I am releasing the hinge support and giving a unit displacement in the direction of action, and I am giving a unit displacement here. Unit displacement means that is 1. Okay, I am giving the unit displacement. So what should be the deflected curve? This deflected curve is look like this. Okay, so this is actually, it says Muller-Bristleben says this is the influence line diagram of RA. Naturally, in previously you have learned about the influence line diagram of RA, this one. Okay, so it look you don't have to go to the derivation, just by observing the geometry of this deflection shape, you can determine the RA. Okay, reaction at RA. Now what is the proof actually? What is the proof that it will be RA? Suppose for here actually, suppose some distance apart the ordinate is x. Okay, so suppose this ordinate is x. So the if you give a unit displacement at A is equal to 1, this one is unit, you have determined this is unit. So what will be the external work done? So according to external work done, RA into 1. So RA into 1, and this deflection x, and why x is downward? Because this deflection is upward, so this will be minus x, okay, into 1. So if a unit load is here, okay, so what should be the reaction? It will be x, RA will be x. Actually this is your
স্যার ওই এক্সটা কি মাইনাস আরেকবার বলুন স্যার ওটা।
actually deflection, if we consider upward direction is positive, okay, but here deflection is from here to this is the downward direction, okay. So the here for this beam, for with respect to this beam, the deflection is downward direction, okay. So external work done, the mouse ta hang kore gelo. So external work done is RA into 1 plus okay. So the deflection is must be opposite direction, okay. So 1 into minus x, okay. So this will be RA into x. So see that you can draw the reaction with the help of the Muller-Bristleben principle, reaction of ILD of reaction RA. Same way you can determine the reaction of RB, okay. Now in case of see that bending moment, so in case of suppose there is a point C, section A, can you hear me? Section A,
ইয়েস
yes.
স্যার, ইয়েস স্যার, ইয়েস স্যার।
So you can draw easily with the help of the Muller-Bresler principle, the influence line diagram. Okay. So influence line diagram actually is very much applicable where you can determine, you cannot determine uh, mathematically influence line diagram like determining structure. Okay. Actually, it convert from geometrical problem to mathematical problem. Yes, yes.
স্যার আমরা স্ক্রিনটা সাদা দেখছি পুরো।
Mm-hmm.
আর স্যার if you can repeat from the ওই x equation then that will be helpful for us.
আজকে কি হচ্ছে এই সময়টা ক্লাস নেই না তো okay this equation so suppose so you are giving a deflection you are giving you are so deflection is 1 okay if you give a RA so if you give so RA into 1 okay RA into 1 okay but this deflection is from here to this deflection is downward so if moving load is here okay so it will be load into the corresponding deflection is downward direction so 1 into minus x here deflection is upward direction and RA is upward direction so this will be RA into 1 okay so the RA into x naturally this is your influence line diagram আমার ইনফ্লুয়েন্স লাইন ডায়াগ্রাম মানে কি ইনফ্লুয়েন্স লাইন ডায়াগ্রাম ধরো এখানে একটা ইউনিট লোড থাকলো ঠিক আছে তার ফলে রিঅ্যাকশনের কত ভ্যালু রিঅ্যাকশনের ভ্যালু উইল বি এইটা এই অ্যামাউন্টটা এক্স ঠিক আছে সো দিস ইজ অ্যাকচুয়ালি রিঅ্যাকশনের ভ্যালু so this is actually RA into x RA is equal to x okay so if you same way if you what is the bending moment variation so suppose at this point what should be the bending moment okay so in case of bending moment what you have to do bending moment means bending moment 0 where bending moment is 0 at hinge there is a bending moment 0 so you have to incorporate a hinge okay at this point in order to draw the influence line diagram at point C you have to release all the constant or the bending constant that means you have to incorporate a hinge here and you have to give a unit displacement that means here in case of bending moment it is be unit rotation okay so if you give a unit rotation here so this is the ILD of bending at C okay so if this is L by 2 this will be L by 2 L by 2 and this is 1 the rotation unit rotation okay so L by 4 L by 2 into L by 2 this is L by 4 so naturally you know that this is AB by L okay that means L by 2 L by 2 into L so this is unit naturally this angle is to same if it is a midpoint okay so this will be half of this and half of this okay so this is actually unit actually এটা কি হয় এটা হচ্ছে এই angle this angle is same as this angle and this angle is same as this angle okay so this angle and this angle is 1 so if it is a midpoint this will be half this will be half okay so this is actually your influence line diagram at moment out C okay now shear force in order to determine the shear force same way okay so shear force same way you can determine shear force so you have to give a here a unit you have to cut here actually you have to cut here and give a unit displacement so this should be 1 okay this should be 1 and এটাকে ধরো এটাকে if you shear force you know one is left up right down is positive so after cutting this you are doing that left up right down of this member so this is left up and this is right down so this is actually 1 from geometry you can find that if this is L by 2 what should be the value of this because this is parallel okay this is parallel to this one So this is actually, if L by 2, what should be the value of this? Okay, this will be naturally half, and this will be half. And if this is theta, this will be L1 theta, and this is, if this is some angle, this will be total is 1, so this will be 1 minus L theta. Okay, same way you can draw the bending moment shear force. If this is not at the midpoint, you can determine same way, just give a unit rotation here. From geometry you can calculate the what should be the shape. This is actually influence line diagram. Just you have to give a unit displacement, that means rotation. Okay. So this is one. Okay, now suppose a fixed end cantilever, and this is fixed end and this is a cantilever beam. So in order to determine the influence line diagram of moment at A, in case of moment at A, you have to, what you have to do, you have to release this moment. So you have incorporated this hinge. Okay, so moment at A, MA, influence ILD of A করতে চাইছো, and you have to give a unit rotation here. Okay, so this is actually unit rotation. If you consider that if you give a unit rotation, so this is your deflected shape, and this is actually ILD of MA. Okay, so naturally this is unit 1. So if the length is L, what should be the value of this? This value will be L naturally. Okay, now if you want to draw the bending moment at any section from here, suppose L by 2 distance apart. Okay, so you have to release it here. You have to give a you have to incorporate a hinge, and you have to rotate one. Okay, unit rotation, give a unit rotation here. So this is 1, so this is L by 2. Okay, so this is 1, and so this is L by 2. So naturally this value is L by 2, and this is your influence line diagram of MB. দেখো এখানে যদি আমার মোমেন্টটা ক্যালকুলেট করতে চাই, এখানে হোয়াট এভার বি দ্য লোড, moment is here is 0, but here if you apply a load, there will be some moment exist. Okay, so in between 0 to B point, A to B point, if there is a load, there will be no variation of MB. So naturally this is no variation of MB 0, and here this is the MB. Okay, now in case of shear force, same way, at this point if you want to draw the shear force, so what will be this shear force? So if you cut this left up right down, okay, right down হয়ে যাচ্ছে, so this is 1. Naturally this is your deflected shape 1. Okay, so this is your shear force. So naturally if there is a load here in this point, so there will be no shear force, and if there is a 1 kilonewton load, 1 unit load here, so here shear force will be 1. এখানে এমবি তে 1 হবে, এখানে আসলে এমবি তে 1 হবে। Okay, so this is the shear force. Same way you can go to the portal frame also. Okay, in case of portal frame, just unit deflection, give a unit deflection. So give a unit deflection. What you suppose here, I have unit shear force actually here. I have cut this section. Okay, this is the this is unit. Okay, and this is the deflected shape. This will remain the 90 degree. Okay, because according to definition, this is a repeat digit joint. Before deformation and after deformation, the load is the before applying this load and after applying this load, the angle will be same. Okay, 90 degree. So in order to keep the 90 degree, the deflected shape will be like this. Okay, so this is your actually influence line diagram of shear force at C. Okay, so from geometry you can determine the what will be the angle. Okay, what should be the this value, this summation is 1. Okay, if this is 90 degree, you have to keep it maintain this 90 degree. Okay, so this is how we can easily calculate, you easily determine the bending moment shear force for a this one. Okay, now in case of RA, suppose In case of array, what you have to do, influence line diagram of array, you have to give a unit displacement here according to this direction. So the reflected shape will be look like this. Okay, so the reflected shape will look like this. So this is your influence line diagram of array. Okay, so uh, this is how we can determine influence line diagram of any section. Okay, এই নোটটা আমি দিয়েছি, নোটটাও দেখে নিও। So actually suppose we'll go to the indeterminate structure, how easily you can determine the influence line diagram. এটা তোমাদের ফোর্থ ইয়ার সেশনালেও করানো হয়, ফিফথ ইয়ার ল্যাবরেটরিতে। In the fourth year laboratory class, you can learn this influence line diagram of this. Suppose this is a two span beam. So suppose this is the two step span beam. Okay, if having the 5 meter into 5 meter and ei is constant. Okay, here for simplicity, ei যদি constant না হয় সেক্ষেত্রেও করা যায়, এটা ইজিলি করা যায়। Okay, so determine the ILD of RA for the continuous beam. So determine the ILD of RA for a continuous beam. Suppose this is 5 meter 5 meter and this is A point, this is B point and this is C point. Okay, so suppose this is a roller, this is the roller and this is hinge. So actually remove support A, remove support A. So first in order to determine according to Muller-Breskel principle, you have to if you draw the array, array, you have to remove support A. Okay, এই সাপোর্টটা রিমুভ করতে হবে and apply a unit force, apply a এখানে আমরা কি করেছিলাম at A and compute the reflection at any point CB and BA. Okay, so the reflected shape will look like this. So if you give a unit force here, okay, so if you apply a unit force here, that what should be the deflected shape? Okay, it will look like this one. সেকশন A সেকশন B শুনতে পাচ্ছ? সেকশন A
Hello, sir.
দেখা যাচ্ছে কি? Okay, so according to Muller-Bresler principle, if you want to draw this influence line diagram of this beam, okay, three-span beam, this is actually a indeterminate beam. So according to, you have to give a unit displacement here, and you have to draw the unit, you have to draw the deflected shape, and this will be your influence line diagram of RA. Now at each point interval, you have to actually determine the ordinates to obtain this curve. ওকে, এ সেকশন বি সেকশন শোনা যাচ্ছে তো, এই দেখা যাচ্ছে তো, এ সেকশন
Yes,
এন্ড বি
sir.
সেকশন, ইয়েস।
Yes, sir, দেখা যাচ্ছে।
So this is your deflected shape, this will be 1. Now how will you determine this ordinate? This is quite difficult to see that what should be the ordinate. Okay, so deflected shape, you do not know what is the deflected shape. In our fourth year class, we do what we will do, we put 3 pegs here. Okay, 3 pegs here, 3টে পেরেক এখানে পোতা হয়। Okay, so now remove this peg A. The peg A is
হ্যালো স্যার,
removed.
আপনি কিছু বলছেন সেকশন বি তে স্যার?
ওহো, আনমিউট করা হয়নি। হ্যাঁ, okay, so what is the A? Point A, RA. In order to determine RA, actually you have to give a unit displacement here. Now this is the deflected shape, this is the deflected shape, and you have to determine the ordinates. So this is your influence line diagram. Now the problem comes that what should be the ordinate. Okay, in fourth year class, what we'll do, we will put a 3 pegs here, 3টে পেরেক পোতা হয় এখানে, and we will remove this peg A, and a steel scale is bended like this way. Okay, and this is your deflected shape. So easily by graphical method, by drawing, we can determine the ordinates, and mathematically we will also determine the ordinates. How? Let us come to this problem. So first remove support A. I have to first remove the support A, and I have to give a unit force at direction of IA. Okay, give a unit force, not a deflection. So this will be the deflected shape. So what should be the deflection? I have to so I have to give a I have to draw the what should be the ordinates here. Okay, unit force দেওয়া হবে, not unit displacement. But suppose the displacement is 0.5 centimeter here. If you give a unit displacement, so 0.5 centimeter. Now for 0.5 centimeter, this ordinate is this much. ধরো 0.4, 0.3, 0.2 like this way, minus 0.1, minus 0.2 like this way. So for 0.5 এর জন্য কত, ইউনিটের জন্য কত? So actually this will be unit quantity. So come to the example actually. So first remove support A, apply a unit force at A along RA, and compute the deflection of any point CB and BA. Okay, so compute the deflection. So this BC and BA, this support. Okay, now divide the deflection at displacement at A. So whatever the deflection, like 0.5 centimeter, whatever it comes, okay, you have to divide it with the deflection quantity. This is the deflection. Have to give the deflection, divide the deflection. So suppose for this example, this is the deflection is suppose YAA means load it at A, load is at A, and you are measuring the deflection at A. Okay, YAA means you load it at A and you are giving a deflection at A. Okay, and YXA means that means at X position, what should be the deflection if the load is situated at A. Okay, YXA, if we denote YXA is the what will the deflection at X at point A. Okay, so this is YXA. Now if you divide the two beam into two sections, like in BC portion and AB portion, that means this portion and this portion. So this is your reflected shape. So I call you this is IXA from x distance apart C point. What should be the bending? And at x distance apart from AB span, what should be the deflection actually? What should be the deflection? So first, let us see. So for this type of three beams, actually summation V is equal to 0. Okay, so summation V is equal to 0. That means RA plus RB plus RC is equal to 0. Okay, this is one equation. Another equation is if you take a moment about C actually. Okay, moment about C. So RA into 0, RA into 0, sorry, RA into 10. This is actually clockwise, so positive. RB into সবসময় আমি ধরে নিচ্ছি তিনটেই হচ্ছে আপওয়ার্ড ডিরেকশনে কাজ করছে। So RA, RB and RC is acting simultaneously in upward direction. Okay, if it comes negative, then our assumption was wrong. It will be in downward direction. So let us assume first that RA and RB or RC is acting upward direction. So naturally RA into 10 into RB into 5 is equal to 0. So if you take a moment about C, okay, so RB is equal to -2. Okay, naturally RB is equal to -2. So and RB is equal to -2 because RA you have given RA is equal to 1. Okay, এখানে একটা ইউনিট ফোর্স অ্যাপ্লাই করা হয়েছে। So RA is 1, naturally RC is equal to 1. So RB is equal to -2 means our assumption was wrong, it was in downward direction. Okay, now if you take a moment about X, any section at X, okay, suppose we are taking a moment here. Okay, if this is in BC region, just simple mx is equal to minus d2y dx2 ei. Okay, so from this point to this point, this distance is x and RC value 1. So naturally 1 into x, the bending moment is 1x. But if the x is situated from here, this suppose this x distance is situated in the BS span, so in that case, in addition to that 1 into x, in addition to 1 into x, 1 into x, you have to put -2 into x minus 5. Okay, so this will be -2 into this one how much? X minus 5. Okay, so -2 b into x minus 5 বোঝা গেল? So if এই ডটেড ডেটা আমি দিলাম কারণ কি
স্যার ফার্স্টে আপনি হ্যালো স্যার ফার্স্টে ছোট মতো যে ডিসটেন্সটা ওটাও তো এক্স বললেন।
হ্যাঁ, yes,
যেটা সি থেকে
yes, first if the distance is situated দাঁড়াও, suppose the distance is situated here in the BC span. Okay, suppose the distance is situated in the BC span, so like x distance apart here. So what should be the bending here? What should be the bending moment? RC into x. That means RC means 1 into x. So this is 1x. Okay, but if x is situated here, next what should be the bending moment? RC into x minus, so RC into x plus RB into, in that case b comes into picture na, RB into x minus 5. Okay,
হ্যাঁ এবার ঠিক আছে, এবার বুঝতে পেরেছি।
so in that case so if the span is situated in this BC region, so it will be only 1 into x. But in the if it is situated into AB region, in that case this will be the total 1 into x minus 2 into x minus 5. RB value is -2. Okay, so you have to keep in mind the dotted. Why I am giving the dotted? Just simplicity. But in case of ei is not constant, what you have to do? You have to do separate way. So in that case 1 by ei will be here it will be 1 by 2 ei. Okay, understand that if this is ei and this is 2 ei, so what will be this in that case? In that case, you have to keep in mind that this will be here it will be 1 by ei, it will be 1 by 2 ei. Okay. Now let us simplify it. Ei d2y dx2 is equal to minus x plus dotted means if this span is situated in this region, BA region, okay, x minus 5. So naturally, if you integrate it, you can get a constant c1 minus x square by 2 plus c1 plus x minus 5. And if you again integrate it, you can get another constant eiy is equal to minus x cube by 6 plus c1x plus c2. Okay, so this is another constant, so c1 into x are একটা term আসে. Okay, so you have to integrate it 2 times. So how can you get the c1 and c2 constant? You can get the c1 and c2 constant from the boundary condition. What should be the what is the boundary position, what should be the displacement, what should be the bending moment shear force? You can get the boundary condition. Suppose at x distance x is equal to 0, y is naturally 0. এখানে at point C actually the deflection is 0 because there is a hinge support. Okay, deflection is 0. Naturally B point this is a hinge support, so here also deflection is 0. So at x is equal to 5 and x is equal to 0, the deflection y is equal to 0. So hence C2 is equal to 0. C2 is equal to 0. এখানে যদি তুমি যদি put করো, okay, here if at x is equal to 0, deflection is 0. Okay, so naturally C2 is 0. And here if at x is equal to 5, okay, next y is 0, deflection is 0. Okay, so naturally here if you put deflection here, x is equal to 5, okay, you can get the c1 value is 4.167, this one. Okay, at x is equal to 5, y is equal to 0. Okay, বোঝা গেল? সুতরাং আমি দুটো বাউন্ডারি কন্ডিশন থেকে দুটো ডিফ্লেকশন, এখানে ডিফ্লেকশন 0, এখানে ডিফ্লেকশন 0, we can get easily the deflected shape, the constant c1 and c2. Okay, so actually we are considering that clockwise moment is positive. Okay, here, so naturally if you put if you at any point at any position the deflection yxa means I have told that at a position, if the load is applied at a and deflection at x, okay, it will be 1 by ei. So এখানে যদি 1 by ei টা এদিকে আসতো তাহলে হচ্ছে 1 by ei হতো, এখানে 1 by 2 ei হয়ে যেত. So 1 by ei minus x cube by 6 plus c1x, that c1 value is c1x, this one, plus x minus 5 whole cube. Okay, this is dotted portion if because if x is within BA region, the whole region, this one, আর যদি এই রিজিয়নটা হতো তাহলে শুধুমাত্র আমাকে এটা নিতে হবে. Okay, now actually at x is equal to 10. Okay, so what should at x is equal to 10, this value is yaa. So what is the deflection at x is equal to 10? That means in this position, what should be the deflection? Suppose 5 centimeter or like something like that. So I have to divide it. Okay, so at x is equal to 10, ya, what should be the value? It should be unit. Okay, it should be unit, but here it comes that 1 by ei minus 166, just put x is equal to 10. Okay, just put x is equal to 10 and you can get ya is nothing but 1. It should be 1 actually. So by simplifying you can get minus 83.33 ei. Okay, so naturally you have to divide it. 5 সেন্টিমিটারের জন্য কত, তাহলে 1 সেন্টিমিটারের জন্য কত হবে, just you have to divide it because you have to convert it into unit. Okay, ya টা ইউনিটে আনতে হবে, এটা it should be 1. So if you divide it ya, you can get 83.33 and ei কেটে যায়. Okay, so this is the simplification. Minus x cube by 6 plus 4.167 into x dot x minus 5 whole cube. Okay, now put x is equal to 1 meter, 2 meter, 3 meter. Okay, like this way. Suppose point C, x is equal to 0. Put x is equal to 0, you can get x is equal to the deflection is 0. Put x is equal to 5, the deflection is 0. In between them, put x is equal to 1, 2, 3, 4. Okay, naturally you can get the minus quantity. Why it is minus? Because it is in downward direction. You are giving a applied force here. You are giving applied force here, and the deflection here is downward. Okay, so this is actually downward direction. So this is the negative. Okay, this portion, this portion, this portion, this will be negative, and this will be positive, and this will be 1 naturally. Okay, so let us see. This will be minus. Just put value x is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 6, 7, 8, 9, 10. If you put a 10, it will become automatically 1. In between them, you can easily determine this curve. This curve will be look like this. So this is the influence line diagram of RA. So what we are doing, আরো অনেক ভাবে মেথডে করা যায়, এটা আমার সবচেয়ে সিম্পল সোজা লেগেছে। Just give a unit display unit force here there and measure the deflection at each point and convert the and measure the deflection at this point where unit force is applied. Divide this force to all the ordinates. Okay, you can get the influence line diagram of RA here. Okay.
স্যার এক্সটা ওই 1/83.33 মাইনাস এক্স কিউব বাই 6 ওখানে বসাচ্ছেন তো?
হ্যাঁ, এখানে বসাচ্ছি। এক্স্যাক্টলি, এটা এখানে বসাচ্ছি। এটা অ্যাকচুয়ালি কি,
দেন
এটা
ওটা বসালে আরএ পাচ্ছি।
হ্যাঁ, এখানে বসালে আরএ পেয়ে আরএ পাচ্ছি না। ইনফ্লুয়েন্স লাইন ডায়াগ্রাম অফ আরএ, আরএ এন্ড আরএ influence line diagram of RA is different. Okay, this is the influence line diagram. In RA and RA influence line diagram is different. Okay, so 5 সেন্টিমিটারের জন্য যদি আমার এটা হয়, এখানে আমি অ্যাকচুয়ালি ডিফ্লেকশন YA পেয়েছি। 5 সেন্টিমিটারের জন্য হয়, তাহলে 1 সেন্টিমিটারের জন্য কত? This is the actually influence line diagram according to Muller-Brewster principle. You have to give a unit displacement there, and you have to give you have to find out the deflected shape, and deflected shape will give you the influence line diagram of that component. Suppose here this is a reaction component RA. Okay, ঠিক আছে। Now in case of RB, এটাও করানো হয় তোমাদের ল্যাবরেটরিতে। Okay, so remove the support B. So you have to in case of remove the support B, naturally you have to give a unit force there, and you have to measure the deflection. Now measure this deflection at B. Okay, divided all the deflection, you can get the influence line diagram of RB. Okay, so here see that remove the support B, remove the support B, apply a unit load at B. Okay, determine the general deflection. Suppose here it is YXB. YXB denotes that at X point you are measuring the deflection and the load is applied at B. And YBB at B, YBB at B means that this the deflection is here YBB. Actually you have to divide it YXB by YBB. এখানে ধরো YXB পাওয়া গেল, so actually এটা যদি YBB is equal to যদি যা আসে এটাকে ইউনিটে আনতে হবে, so this will be YBB. Okay, this will be a deflection. This is the influence line diagram. So what you will do, so RB is equal to 1. So actually first you have to determine that you have to give a unit force here, unit force upward direction. So RB is equal to 1. Okay, naturally from symmetry you can determine that RA and RC is equal to -5, or otherwise you can do if this is not symmetry, you can go to the bending moment about any point A. Okay, you can determine RC, and from here you can determine RA. So RA and RC and RA is 0.-5. That means our assumption is upward direction is wrong, is in downward direction. So let us start upward direction ধরেই করা হয় RA RC করে -5 just put করা RA RC যখন ভ্যালুটা পুট করব তখন -5 বসাবো, -0.5. So same way I have to draw the bending moment from RC, from C point, first X distance apart. Okay, next this will be from X distance apart. Okay, so first so RC value is 0.5. So here what should be the bending moment? Here suppose this is X distance, so this will be -0.5 into X. This is the bending moment. Okay, and if this is situated in this region, so this will be -0.5 into X, minus 0.5 into x plus rb into x minus 5. This one will be, if this is x, this will be x minus 5. Okay, so 1 into x minus 5. This is dotted as same because if this is situated in this region, we will consider in this portion, and if we situated in this region, we consider the whole portion. So for this discrimination, I am putting the dotted line. So ei d2y dx2 is equal to minus 0.5 0.5x minus x minus 5. Okay, so just এই মাইনাসটাকে এদিকে আনা হলো. If you put this minus in this right hand side, so this will be 0.5x plus minus x minus 5. Okay, so if you integrate it, it can get ei dy by dx is equal to 0.5x square by 2 plus c1, another constant, minus x minus 5 whole square by 2. Okay, if you integrate it, again if you integrate it, another constant comes c2, so c1 will be minus x, c1 into x, so this will be x1 minus 5 whole cube into 3 into 2, so 0.5 x cube by 6. Okay, so this is the integration. Now you can find out c1 and c2 same way using the boundary condition. Okay, so the boundary condition are at x is equal to 0, y is equal to 0. Naturally at point c, this will be naturally point c, the deflection here is 0, and at point a, the deflection here is also 0. At x is equal to 10, the deflection here is 0. Okay, so at x is equal to 10, y is equal to 0. So here c2 you can get 0, and in this equation, if you put c1 is equal to minus 6.25, so this will be c1. So this is the rearrangement of this equation. The c1 and c2 টা তুমি দিয়ে যদি দাও, কনস্ট্যান্টের ভ্যালুগুলো যদি বসাও, এখানে হচ্ছে this is the equation. Okay, এটা হচ্ছে 0. So now yxb is equal to 1 by ei 0.25 x cube by 3 minus 6.25 x. Okay, so minus 0.5 x minus 3 by 3 into cube. Okay, so এটা হচ্ছে yxb at any position x due to the loading at b, unit load at b. Okay, now at x is equal to b, at x is equal to b, that means ybb, মানে at x is equal to 5, x is equal to 5. Okay, what should be the value? If you this value, if you put this value, this will be minus 20.83. Same way you have to divide it, yxb by ybb. Okay, so 1 by minus 20.83, this is your result. Okay, now put into this is actually influence line diagram. Now put x is equal to 1 2 3 4 5 6 7 8 9 10, same way. Okay, so if you put x is equal to 0, naturally it will be 0. X is equal to 10, it will be 0. At x is equal to 1, that means at the position of b, okay, naturally it will be 1, and in between them this will be this. Okay, naturally this is symmetry, so this will be equal, this 7 point and 3 point will be equal, এটা same, এটা same. Okay, এটা symmetry যেহেতু আছে, symmetry না হলে হবে না. Okay, so this is your reflected shape. Okay, naturally you can get that this is actually 1, this is 1, this is 0, this is 0, and in between them, ধরো এই পয়েন্টটা আর এই পয়েন্টটা, এখান থেকে 1 মিটার ডিস্টেন্স, এখান থেকে 1 মিটার ডিস্টেন্স, এটা সমান হবে। এখান থেকে 2 মিটার ডিস্টেন্স, এখান থেকে 2 মিটার ডিস্টেন্স সেম, 3 মিটার ডিস্টেন্স 3 মিটার ডিস্টেন্স সেম, 4 মিটার সেম, 5 মিটার সেম। সিমেট্রির জন্য এটা হচ্ছে। ওকে, সো এনি কোয়েশ্চেন? এনি কোয়েশ্চেন সেকশনে? সেকশন বি
স্যার আর একবার ওই জায়গাটা দেখাবেন যেখানটায় ক্যালকুলেট করলেন আর এর ওই লাইনটা,
আরে না আরবি,
মানে আরবি, সরি আরবি, এটা না স্যার, ওই লাস্ট যেখানটা রেজাল্ট বেরোলো আমাদের।
ইয়েস, এখানে So at x is equal to 5 meter distance.
এটা না স্যার, এটা না, রেজাল্ট যেটা বেরোলো, যেটা
আচ্ছা
আমরা
হুম হুম
এক্স এর ভ্যালু গুলো,
পুট করে হ্যাঁ
স্যার এটা বলছি যে যতক্ষণ না 1 আসে আমরা ততক্ষণ করে যাবো। ওই যে সাপোর্টার
হ্যাঁ
1,
1 এর সাথে করে
সাপোর্টার
যাবো
ডি
না
1।
কোনো মানে নেই, 1 আসে করে যাবো এটা না। ওকে, যেটা প্রবলেম হচ্ছে এটা 1 আসবেই, কারণ আমি এই যে ভাগ করেছি না, যে ভাগ
হ্যাঁ
করেছি, এই যে ডিফ্লেকশন কত, এই ডিফ্লেকশন বার হচ্ছে ইউনিট লোড অ্যাপ্লাই করার পর
হ্যাঁ, ওটা
-20.8।
আমরা ইউনিট লোড করার জন্য, হ্যাঁ
হ্যাঁ এটা ইউনিট ডিসপ্লেসমেন্ট করার জন্য আমি বার করছি। এখানে ডিসপ্লেসমেন্ট এতটা বার হয়েছে, এতটা ডিসপ্লেসমেন্ট হলে এর যে ইকুয়েশনে হচ্ছে এটা, তার মানে আমি একের জন্য কত হবে, ইউনিটারি মেথড ঐকিক নিয়ম, একের জন্য কত হবে, তাই জন্য এটা -20.83 দিয়ে ভাগ করা হচ্ছে। এটা ইআই কেটে যায়। ওকে, এটাকে একে কনভার্ট করা হচ্ছে, এক আসবেই এখানে। ওকে, এটা একে আসবেই। ধরো এখানে ডিসপ্লেসমেন্ট এসছে 5 সেন্টিমিটার, এটা করে দেখা যাবে x = 5 বসালে 5 সেন্টিমিটার, এখানে এর ভ্যালু বসালে দেখা যাবে 5 সেন্টিমিটার ডিসপ্লেসমেন্ট এসছে। অ্যাকচুয়ালি আমার এখানে 1 সেন্টিমিটার ডিফ্লেকশন আনতে হবে, তাহলে আমি কি করবো, 5 দিয়ে ভাগ করবো, তাই না? পুরো, তাই জন্য প্রত্যেকটা অর্ডিনেটকে আমি 5 দিয়ে ভাগ করছি। ধরো এটা ভ্যালু হচ্ছে 5, প্রত্যেকটা ভ্যালু অর্ডিনেটকে আমি 5 দিয়ে ভাগ করছি। ন্যাচারালি এখানে 5 সেন্টিমিটার ডিফ্লেকশন যেখানে আসবে 5 ডিভাইডেড বাই 5, সেটা একই চলে আসবে। ঠিক আছে, এখানে একই চলে আসবে, এখানে তো 0 আসবেই, এখানে 0 আসবেই। এখানে ধরো 3 সেন্টিমিটার ডিফ্লেকশন এসছে, ঠিক আছে, এখানে 5টাকে কনভার্ট করেছি 1, সুতরাং 3 সেন্টিমিটার ডিভাইডেড বাই 5 সেন্টিমিটার, সবকটাকে কনভার্ট করা হয়েছে, এই যে ভাগ করে দেওয়া হলো। ওকে, কারণ এটা ইউনিট আনতে হবে, আমি এখানে ইউনিট ফোর্স অ্যাপ্লাই করছি, নট ইউনিট ডিসপ্লেসমেন্ট। ইউনিট ফোর্স অ্যাপ্লাই করার পর ওইখানে ডিসপ্লেসমেন্ট মেজার করছি, হোয়াট এভার বি দ্য ডিসপ্লেসমেন্ট, আমি সমস্ত ডিসপ্লেসমেন্টটাকে ওই ফোর্সটা, ওই ডিসপ্লেসমেন্ট দিয়ে আমি ভাগ করে দিচ্ছি। ঠিক আছে, ওইখানকার ডিফ্লেকশন যে অ্যামাউন্ট, ধরো 5 সেন্টিমিটার ডিফ্লেকশন হচ্ছে, সবকটাকে 5 দিয়ে ভাগ করে দিচ্ছি, এই যে ভাগ করা হচ্ছে। ঠিক আছে, তার মানে এটা তখন একে চলে আসবে, আর এটা যা কোয়ান্টিটি আসবে তাই আসবে। এটা যদি আমি এটা যদি না ভাগ করতাম, তাহলে এটা কি আসতো, এখানে 5 সেন্টিমিটারই আসতো। ঠিক আছে, এটা 5 সেন্টিমিটার আসতো, এটা আসতো কত, এটা আসতো হচ্ছে 5 × 0.994 যা আসতো, এটা হচ্ছে 5 × 0.78। যেহেতু আমি এখানে ডিসপ্লেসমেন্ট, আমি এখানে ইউনিট ফোর্স দিয়েছি, এখানে ডিসপ্লেসমেন্টটাকে মেজার করেছি, এখানে যা ডিসপ্লেসমেন্ট এসছে সেটা সব দিয়ে ভাগ করেছি, সব দিয়ে ভাগ করার পর এটাও ভাগ হয়ে গেছে। ঠিক আছে, তাই জন্য এখানে 1 সেন্টিমিটার হলো। ঠিক আছে, বোঝা গেছে?
হুম স্যার, বুঝতে পেরেছি।
এটা আগের ক্ষেত্রে, প্রবলেমের ক্ষেত্রে তাই হচ্ছিল। নাও আজকে আর ভাল লাগছে না, ঠিক আছে, এর পরের দিন জানি না, এটা তোমরা বুঝে নিতে পারবে আর কি। দুটো প্রবলেম আছে, তোমরা বুঝে নিতে পারবে। সো ইফ, এটা বলে দিচ্ছি ওপর ওপর দিয়ে, একই সিস্টেমটা একই। সো সাপোজ there is a point, okay, suppose this is 9 meter, this is 6 meter. So at D point, what should be the shear force, sorry, bending moment distribution, bending stress distribution. Okay, so this will be like this way. You have to give a unit force here, so this is unit. Okay, now introduce a hinge at D, এখানে একটা hinge apply করবে, apply a bending moment at D. Okay, apply a unit bending moment at D, এখানে unit bending moment হবে, যা রোটেশন পাবে সেই রোটেশনটা সব জায়গায় স্লোপ দিয়ে ভাগ করে দেবে। ওকে, dy by dx is your slope. Okay, so yxt, suppose you have got obtained theta dd, here you have obtained theta dd, so at each slope here, এখানে যা যা স্লোপ পাচ্ছ সেটা সব দিয়ে ভাগ করে দেবে। So this is your bending moment. ওকে, সো এই যে স্লোপটা দিয়ে ভাগ করে দেবো, এই যেখানে পাওয়া গেছে, এই যে এখানে করা আছে। দেখি পরের দিন যদি ভালো লাগে এটা আমি করিয়ে দেবো। যদি শিয়ার ফোর্স থাকে কি হবে, ডান দিকে ধরো একটা শিয়ার ফোর্স আছে কাটা, এই যে এটা শেপটা হচ্ছে এইভাবে। ওকে, নাও ইফ দ্য শিয়ার ফোর্স, জাস্ট গিভ এ ইউনিট দিস force here, unit shear force, this is the deflected shape, determine the what should be the this deflection. Okay, just divide it, okay.
ঠিক আছে স্যার, আমরা দেখে রাখবো, তারপর নেক্সট
দেখে
দিন
রাখো,
আপনি
যদি
তারপর
কোনো
এটা
প্রবলেম
দেখিয়ে
হয়
দেবেন।
তাহলে
হ্যাঁ,
এটা করে দেবে, আমরা বলবো।
ঠিক আছে, ঠিক আছে,
ঠিক আছে,
থ্যাংক ইউ স্যার।
হ্যাঁ ঠিক আছে, থ্যাংক ইউ।